All right, for all those people that finally showed up here today, you know what? Happy New Year. So, class. Okay. All right. So, getting back to doing some math. For some of those people, 4.1 was one of those ones that we actually had over break, but then I made it to this week. So hopefully you guys actually did 4.1, but we will have one more time here in a little bit. So 4.2, min, max values, and critical numbers. So identify absolute maximum and minimum values and local extreme values of a function. So this is important, okay? Definitions are important. There's a reason for that because it's going to mean if something qualifies or does not. Let a function be defined on an interval I if there is a number u in the interval for which f of u is greater than or equal to all of f of x. For all x and I, then it has an absolute maximum. At u, then the number f of u is called the maximum value. Absolute maximum value. That means plug x into that value. That's basically asking for the y value for that certain x. That's important. It's asking for the y value, not the x value. If there is a number v on I for which that f of v is less than or equal to f of x for all x and I, then f has an absolute minimum at v, and the number f of v is the absolute minimum value of f on I. The values fu and fv are sometimes called absolute extrema or the extrema values of f on I. Extrema is the plural of the Latin word for extremium. Extremium? Extremium. Extremium? Extrema. Extrema. Extremium. Extremum? Extrema. I think that sounds right. Extrema. All right. So, right here. So, if you know, right here, u is the value that we have right here in between my interval. And so my values of the function, the absolute maximum value would be the f of u. So if it's asking for where is this, you would say it's u would be the absolute maximum. And if it's asking for the value, it's asking for f of u. Same thing over here for v. That is a minimum, and it is the value f of v. Any questions over that? So I know I said a whole lot of words on this first Monday of the school year, first thing in the morning, and most people's brains aren't on yet. So, are we at least following here? Oh, okay. Local extrema values of a function. Okay, this is important. So let f be a function defined on some interval I, and let u and v be numbers in I if there is an open interval in I containing u so that f of u is greater than or equal to f of x for all x in this open interval, then f has a local maximum or relative maximum at u, and the number f of u is called a local maximum value. Similarly, if there is an open interval in I containing v so that f of v is less than or equal to f of x for all x in this open interval, then f has a local minimum. Relative minimum at v, and the number f of v is called the local minimum value. Term local extreme value describes either local maximum or minimum value. All right, identify local extremes. So u, this u1, is going to be a local maximum. It is a maximum over this area right here. Okay, in this group, just a small interval of that. That's one way to actually look at it as it's local. It's a smaller area of this, okay? Local minimum, right here. It's not the whole minimum, but it is local. This right here is a maximum. It's local to this spot right here. Now, does this one have a absolute maximum? Yes. It does have an absolute maximum. Does it have an absolute minimum? No. You notice over here on A and B, are those included in my interval?
Yes.
No. What's missing? Look at my maximum. And now look at the A and B. Point. What type of interval is this? Open interval. If it's open, is it equal at this end, these ends? No.
Well, wouldn't there still be a minimum? The minimum wouldn't be 0, but it would still be
No.
minimum.
It wouldn't have one.
Why not?
Because it doesn't have a value there. We have a value that approaches that number, but it is not that number.
We still have a value next to that value.
We have one next to it, but is infinity a number?
It's not infinity.
But is it at that number? No. Does it get infinitely close to that number?
Yes.
Yes, it does. But I don't have a number. I have a number close to that number. It is a open interval versus closed. Closed is bracket and has a closed dot. Open is a parentheses and has a open dot. So this one, I would say it does not have those. All right. Now, you guys all have this on your notes right now, so let's go ahead and try and fill this in. Let's see if we were following along. What is the domain of my graph? To what? 3 pi over 2, yes. So, are we bracketing both of those? Yes. We bracket both of those. Determine where the function is continuous.
But with parentheses?
Yep. It's continuous on the open interval from 0 or pi over 2. Because at the end points, we don't consider that. Because we're saying it's everything in between is continuous. Identify the absolute maximum value and the absolute minimum value, if they exist. Okay, help me out.
It stops.
Yeah, it stops. So it's continuous for everything in between there. Okay, so hold on. Let's go absolute maximum value. What's my maximum value? 1. Okay. Definition of words is important. Maximum value, that means it's looking for the y value. Okay. All right, minimum. There we go. All right, find domain, and we already did domain, but identify local extrema values. Does it have a maximum? Yes, this one is included, right? That is a solid dot. So it's an absolute max. Oh, you're right, sorry. I was, absolute max. Okay, now, this one, it's not a local. It's not a local. It has to be in between, two areas. So endpoints cannot be local. That's the best way I actually try to remember it as. An endpoint can't be a local.
Wait, there are none? But that's also.
It can be. It could be a local and an absolute. Remember when we did this one over here? This is a local in between here and here, right? And it just so happened to also be the absolute max for here to here. A local can be an absolute also.
But why can't the local be an endpoint?
Because it has to be. So see right here? Right here. Local would refer to that it's from this side. So if this went down a little bit right here, this would be a local. What you looking for, homie? What'd you guys do with 4.2? Oh, it's right there. So again, that's why I try to remember it like that. Local cannot be endpoints. So local extreme value. So the only one that we have is local max. Oh, I'm sorry. Local min is -1. No local max. When we get to the definitions of it later on, you'll understand why. Like the full definition, like actually finding it mathematically, you'll see why that happens. So. Okay. Identify absolute local extrema from the graph, each of the function on the next slide. So A through D, you're going to do for each one of these right here. Kiss that. Is that your Tupperware? I thought it was yours, so I just left it alone. It's been there. That's not yours. Okay. Do we need to redo the first one? No, because it's the same as what we had, right? Okay. All right. What about figure 11? Domain. How am I opening it? Parentheses. -1 to 3.
Yeah.
Close parentheses. All right. What was after domain?
Function's continuous.
Continuous. Is it continuous?
Yes.
Okay, from -1 to 3. What came after that?
Absolute maximum and absolute minimum.
Absolute max, absolute min. So absolute max is going to be?
1.
Okay, did it? Absolute maximum value, maximum minimum. So max
1.
is 1, min
7.
-7. And what's the last one? Local? Okay, so my local would be same things. All right, what about this next one? What's the domain?
Parentheses -1 for bracket.
Comma, for bracket. Very good. All right, it is continuous from?
-1 to 1.
So all those places in between. Max? No max. Min? What is it? It is. It is a absolute, isn't it? So it is a min.
But there's no extreme values.
There's no local. And no local.
Why is there no local?
Where did I say local have?
Oh, yeah.
Can't be endpoints, right? Now, this one over here, does it ever, it keeps going up infinitely, right? As I get closer and closer to -1, so it goes up to infinity, doesn't it?
Yeah.
Okay, so I can't get a maximum number off of that. But I can get a minimum, right? And local can't have endpoints, yes.
Why would there be no brackets on 11, bigger than if it's on the x-axis?
Because the points are open.
See this right here? Yeah. Open dot. Open dot. And like on this one that we just did, these are closed dots. So that's why we include those. All right, let's go through this pretty quickly here, and then we can get to working on some of the homework problems. All right, figure 13. Domain is from
Parentheses 0.
E. Is it continuous? I don't see anywhere that's not. Min max?
Max. It looks like mine is 2.
These are orange.
Oh no, because it's so no.
Nope. No absolute and no locals, right? Okay, this next one. All right, And my interval starts at 0. Oh, bracket, yes, thank you.
6, bracket,
So 0, comma
6,
6.
yes.
0, comma, like a bracket, 0, 2, comma.
No, because it's still, the domain, it still covers all of the points.
It does. It does,
So
yes.
it would just be 6, yes.
And it goes all the way to 6. And how do we close that 6?
Bracket.
Okay. And is it continuous? So it's continuous from 0 to 2
Parentheses.
parentheses union 2 yes, bracket, because that one's a closed dot.
Wait, but I thought we didn't use brackets when it was continuous or not.
That's for when they were
That's
ending.
what you
Yeah,
said.
endpoint. So, but this one right here picks up again at this point, because as we're reading this, we have to be able to see where it's actually going to be that jump. So this approaches 2 from the left, but it's not equal to 2.
But it's not continuous at 2, and that would say that it's continuous at 2, but it's not. It says no.
It's not saying it's continuous, it's saying which one's open and which one's closed.
Yeah, so it goes to here, from here to here. These are together. So 0 to,
But in the other ones, when it was brackets, you still
we didn't have any jumps. We didn't have any discontinuities. Right now, we have a big hole right here. Why we want to ride that roller coaster? No. No.
Well, yes, but you would still use, because at 2, where it is at 6, that is continuous because one side there isn't anything, so it's not continuous at that specific point.
No, I'm just saying. So at the end, not gonna bracket that one. I'm gonna parentheses out.
Yes.
So it's continuous from here to here.
Yes.
So it's saying where this is actually picking up at. And this would be to 6, like that. So it's from here to here is what we're talking about, because if I just put here to,
Look, if you just change the bracket to a parentheses, what would? Because if you ignored the first part and you were just trying to find the continuous.
I know what you're saying. I really do. Now I'm actually second guessing myself.
Then it wouldn't make sense to have the 2 in parentheses, two twos in parentheses.
But if I'm reading this,
Then I would say that
if I'm reading this, so you would just have this information. Would you be able to draw something to go along with just this information here?
Yeah, I mean, yeah, 'cause it tells you that it picks up it's a solid dot.
But how could something be continuous when half of it, or when one side is there?
This side is continuous.
And it picks up exactly at 2.
Picks up at 2, but these are my x values, not my y values.
Yes. But why would you have to?
Do you want me to double check? I'll double check it. I don't have a problem. Because now you're making me question it. Like, oh, alright. Let's see. I will double check the notes. And hopefully, I am not making a fool out of myself. It's not hard to do, though. Oh, okay. So I got it wrong on this part. I'm right at the other thing though. So it's these right here which I was getting wrong. And so therefore that means I got this one. Yeah. So right here. Open. This one right here should have been.
So it's the same as the domain.
Yeah. So this one should have been brackets. So
It's continuous on that point.
Yeah.
Okay.
So that's where I made a mistake. But yes, is this in the book? It actually says everything except for 2. So they did everything in interval notation, but then they did that one in a different type, the set builder. Maximum. It has an absolute max where?
6.
At 6. Absolute minimum at -2. Has a local maximum. No, wait. It has a local minimum
0.
at 0. No local max. Because this does not keep coming down. If that kept coming down, that would have been local. And again, can't have local at the endpoints.
What would the local minimum and maximum?
Actually, okay, good thing I'm checking my notes on this. There is a local. So there is a local max, and they say local max is 6. Local min is 0.
Oh, yeah.
All right, this last one.
Wait, for 13, why'd you put E for one?
What?
Why'd you put E?
Because this number right here is E.
Oh, yeah.
Okay, so this one right here, it is domain from bracket -2, comma 2 bracket, and then this is going to be a bracket -2, comma 0 parentheses U 0 2 bracket. All right, absolute max.
3.
Yep, it has 2 places where it's 3. Absolute min.
No, there's
No.
one.
It doesn't have one. Why does it have one?
Because it's open.
Because that's open right there.
Should there be a local one at 2?
Yes, local at
It's
2.
the same as the min, well, there's no point in saying that the minimum is negative.
And since this one is actually going down and going up to this is a CAL at 2. Alright, so I'm going to leave off there, and then we're going to do some of that homework problems that you guys have questions with. Alright,